Yo, Tabang Fana Boss. So, halala right now. Greetings. Let's talk about average speed, average velocity, and acceleration. Why Bonatab? Remember that in our previous session, of course, we've tried to introduce ourselves to physical properties, tried to classify as to whether these physical properties, being speed, being velocity, being acceleration, and others, as to whether are they perhaps vector quantities, or maybe they are scalar quantities. Why Bonataba mfuna boss? So almost blind. Halala right now. So we've advanced our knowledge, of course, tried to introduce ourselves to the concept of speed versus displacement. Why Bonataba? In today's session, of course, now we want to introduce ourselves to the concept of speed, velocity, and acceleration. Why Bonataba? But whatever we do, remember that we are guided by the learning objectives. We are guided by the physical sciences examination guidelines. We are guided by the Holy Bible of physical sciences, so I say. Now, the first learning objective, according to the physical sciences examination guidelines, of course, is to have the ability to define average speed. So you must know as to what exactly are you talking about when you talk about average speed. Now, by definition here, it seems like they say speed is obviously the total distance traveled per total time. So for speed, we use what? We use distance, which is a scalar, and we use time, which is a scalar. Now, you can agree with me that those two physical quantities are both scalars. So therefore, it will make sense, therefore, for us to have average speed as well, being a scalar quantity, a quantity that only has a what? That only has magnitude. That's why here they say you can't go to that physical sciences examination not knowing what average speed is and not knowing as to whether it's a scalar or a vector. Halala right now. And then we tried to introduce a nice triangle here to try to remember, of course, as to what is speed, what is distance, what is time, and all those things. We said, okay, we have a triangle like this, DSTV. Well, unfortunately, V didn't have space. Perhaps that's why sometimes we use V instead of S for speed. We use V instead of S for velocity as well. Why Bonataba? So we will use V instead. Now our DSTV triangle will be very helpful. For instance, if we are looking for speed, we will agree that speed then will be the distance covered over the time taken, which is of course the definition of the concept average speed. For we have said that, well, for us to define average speed, we must mention that, well, average speed is the total distance traveled per total time. So halala right now. They say so you can't go to that physical sciences examination, you just can't, without having the ability then to define average velocity. So they will say define the concept or define the term average velocity. Well, you will hear the concept rate there, which is a very, very important concept in physics. We'll try to explore what does rate mean. So they say average velocity is the rate of change of position. Do you remember position? We said, well, it is delta x when we were talking about displacement. Position, displacement, synonymous. Same shit in boss. Now, they give us an equation here to say, well, velocity then, or average velocity, is the change in position per unit time. So every time we hear the word rate, we know that in the denominator, we will have what? In the denominator, we will have time. Every time we hear of the word rate, in the denominator, we will have time. For velocity, we say it is the rate, or yes, it is the rate of change of velocity. What am I saying? So for that, we say then velocity is the rate of change of position, right? So we can see that time is indeed in the denominator. They say, know that average velocity is also a vector quantity. It's a necessity. It's a must for you to know that. So halala right now. They say then you must have the ability to calculate. It's a necessity. It's a must. Have the ability to calculate average speed and average velocity. And remember that for grade 10 level, we are only concerned with one-dimensional motion. And we said, well, One-dimensional motion, of course, is motion in a straight line, motion along a line. For those examinations to be ready, of course, we must have the ability then to convert between different units of measurements, such as that of speed, such as that of velocity. For we know that for speed, because we're having distance, which is in meters, and time, which is in seconds. So it makes sense, therefore, for us to have meters per second for the units of speed, meters per second for units of velocity. Know what is velocity, know what is speed, know as to whether those physical quantities are vector quantities or they are scalar quantities. Right now. So now we are guided by the learning objectives, of course, as to what is it that we must know. We will try to explore a few questions and see as to whether the examination guidelines are indeed our savior or could be our savior in these upcoming examinations. But believe you me, they always will be. They were published around 2015. Today is 2024, but still, these examination guidelines, you just can't go to that physical examination without knowing them by heart and soul. Right now. So we have a question in front of us. They say two friends, Tom Lee James, they are training for an athletics meeting on a sports field of length 200 meters. That's fine. I like the fact that the 200 meters, they've also shown you there in terms of a diagram. Remember that as physicists, sometimes the long English can be boring to us. So we want to make things a little bit more visually appealing. So we can see the 200 meters there, which is of course the length of the sports field. Now they say both friends starts from the middle of the field at point A. So it means this is where they will start with their training. This is where they will start perhaps with running or whatever they'll be doing here. Which means that when they go to the west, there is about 100 meters to the west. When they go to the east also, there is 100 meters to the east. Why? Because remember, this whole sports field takes about 200 meters, but they decide to start in the middle. That's where they decide to start, in the middle of the field at point A. So let us learn a little bit about Tom. Tom is the one who wants us to do some bit of physics here. Right now. Now, Tom runs using two cones. The first cone is placed 50 meters east. Remember, never ever smoke weed. So I like the fact that they've also given it to you there. You must never ever smoke weed. So this person, which is Tom, he runs using two cones. The first cone is placed 50 meters east of the starting point. There is the first cone. While the second cone is placed 40 meters east of the cone once more. So there are the two cones that Tom tried to seek attention with here. Right now. So let us go through and see as to what type of questions they can ask in this regard. But recall something. This is motion in one dimension. Paul can never go up or down. Now he must either go west or east. He must either go left or right. Why? Because this is motion in one dimension. Right now, motion along a straight line. This is the straight line that we are talking of and about. Right now. Try to furthermore explore Tom's motion. We are doing mechanics, and we said mechanics has to do with motion, and here we are interested in the motion of Tom. Tom runs along the following route from starting point A. Remember, we've mentioned that point A is the initial or starting point, due east to cone 1, meaning he ran from the initial point all the way to cone 1 and then turns around and returns to the starting point running due west. I hope you can see what Tom is doing there. He started from the initial point, he went to the first cone, and then he went back to the initial point. So there is something we can say about his distance there. There is something we can say about his displacement there. Definitely, there is something we can say. Perhaps one of the things that we'll recognize that from this first statement here, the displacement in actual fact is equals to 0, because this person started from the initial point, ended to the initial point. His final point was the initial point. Isn't that weird? So that means he had a 0 displacement. As much as he moved a very long distance, 50 meters to the cone, back to the initial point, that's a whole round. But unfortunately, when it comes to his displacement, it's 0. Now they say from point A, due east to cone 2, and then turns around and runs due west, ending at cone 1. Now we can say something about the displacement there. Let's go through the questions. Of course, 2.1, 3.1, 4.1 will always be definitions. Cram those definitions free, 24 marks, I believe. Get those 24 marks. Kimahala mfana boss. Cram. The definition will never change. It will always be as is. Say, for instance, define the term displacement. We know what displacement is. Even the examination guideline tried to explain to us as to what is displacement. Change in position. Now they say write down the final position of Tom relative to the starting point. So of course we will have to go to the scenario there to see what was happening, because we want to write down the final position of Tom relative to the starting point. So I believe for us to be able to answer that question, it will depend on these statements that we have had here. Let's try to draw Tom's motion. So remember we said from starting point, this was the starting point. From the starting point, which is point A, due east to cone 1, there he goes all the way to cone 1. And then when he reaches cone 1, this is cone 1, he then turns around and returns to the starting point, running due west. There he is now. He is at point A. So we have agreed that, okay, the displacement then at this time and moment, the position seems to be 0. But let's see what the second point is gonna say. Then from point A due east to cone 2, there he goes to cone 2. He then turns around and runs due west, ending at cone 1. So they ask a very, very simple question here. In actual fact, what they are asking you is what is the resultant vector of course. That is what they are simply asking here, which is this position here. Remember the question that they asked is what is his relative position, what is his position relative to the initial point. So we can see definitely it's simply 50 meters. But remember that position, it's a vector quantity. By just saying 50 meters, we wouldn't have done justice. We must also include the direction to say, well, Tom will be here, somewhere here, because this is where he ended. There is Tom. I was trying to draw Tom there at cone 1. You can see that from point A, which was the initial point, which was the reference point, of course, he is just 50 meters west, or rather, 50 meters east of that 50 meters east of the initial point. So that will be the solution then. Hello, right now. Let's go to the next question. For question 2.3, they say, the complete route described above took Tom 30 seconds to complete. Tom was very fast, he just took only 30 seconds to complete that. Determine his average speed in meters per second. If you recall, we said average speed is equals to the distance divided by the time. So let us go and explore something here about Tom's motion. We were more interested in the displacement here. We said, well, the displacement is 0, but now the question that we are interested in wants the distance as well. They say from starting point A, due east to cone 1, and then turns around and returns to the starting point running due west. So if we go here and see something, we will recognize something very interesting here in Fanaboso. We can see that, remember, Tom started at the initial point A. He started at the initial point A So that is what we must recall here. Tom started at initial point A. This is where he started. He went here 50 meters, but he went back once more, another 50 meters. So that means from the first statement here, we can then argue that, well, Tom ran about 100 meters. So this is 100 meters. That is the distance. But they say from point A, due east to cone 2, he then turns around and runs due west, ending at cone A. So we are going to go once more and see what is the distance that he ran, therefore, for that particular portion of the motion. So we are saying he started once more from the initial point. He went all the way to cone 2. So you can agree with me that he has about 90 meters now. So we have 90 meters. But he goes back once more to cone 1. So that will be what? That will be 40 meters. So we will add the 90 plus the 40. We will get what? We will have the 90 plus the 40, which gives us nothing else but 130. So Kyotaba Mfana Boso, we will have 130 therefore. We come and write that 130 here as part of the motion. To say here it was 130 meters. Now what you'll do therefore to be able to find the speed will be to say the speed, remember, is the total distance. That is what we usually say when we answer questions. We say, well, speed is equals to the total distance covered per unit time. So what is the total distance covered? It will be the 130 meters plus the 100 meters, which of course will be what? Will be 230 meters. And you divide that 230 meters by 30 seconds and you punch that into the calculator. You will see what it gives you. So you'll have 230 divided by 30, which is equals to what? Let's see. It gives us 7.67 meters per second. We've answered the question. So let us understand that speed is a scalar. It is equals to distance over time. The distance was 230 meters. The time was 30 seconds. And all in all, we have 7.67 meters per second. That is how much he have covered every second. 7 meters. Or 7.67 meters for every second.
Wapela, there were two boys here that we were talking about. Renebuaga James, Renebuaga Tom. I believe that I've done justice with Tom. So we'll go through James and see as to what exactly is it that you must know about James. And if you have any questions, of course, you can ask them in the comment sections and I'll get back to you. So I believe that you will be able to do question 2.4. It's about James motion. Try to analyze James motion. And I believe that you are capable, since it is now time for you to write your SBAs. Soon you will be writing your final examinations and living grade 10. Good luck with that journey. Good luck with that endeavor. So my name is Mr. Mujakisanese. They call me Mr. M. Mfana Boss. So, halala right now. Welcome to Science Intellect Hub.